Hi, today I am explaining geometric meaning of zeros of a polynomial. Before that, we need to know what is zeros of a polynomial and value of a polynomial. The value of a polynomial is obtained when the variables of a given polynomial are replaced by the value of a given variable. Let us see the example. Consider p of x equal x square plus 4x plus 2. We have to find the value of the polynomial at x equal to 2. See here, that means p of 2. Instead of this x, we are giving the value 2. We are replacing the variable x by a given value. Now, in the place of x, we can give the value 2. See, p of 2 equal 2 square plus 4 into 2 plus 2. See here x square. Instead of this x, we gave that 2 plus 4x. So 4 into x. Instead of this x, we gave 2. 4 into 2. Now we got 2 square is 4 plus 4 into 2, 8 plus 2. So we got p of 2 equal 14. Hence, the value of p of x equal x square plus 4x plus 2 where x equal to 2 is 14. That means p of 2 is 14. In general, we can say that if p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x equal to k. So, what is the value of polynomial? We are just replacing the variable with a given value. That's it. Next, we'll see that zero of a polynomial. Zeros of a polynomial can be defined as the point where the polynomial becomes zero. What is that? Zeros of a polynomial can be defined as the point where the polynomial becomes zero. Let us check with the example. Consider the example p of x equal x square plus 6x plus 8. We have to find the point where the polynomial becomes zero. So, at which point this polynomial becomes zero? That point we need to find. That is the zeros of a polynomial. So, we can write this polynomial as 0. Then we can find the value of x. We can rewrite as x plus 2 into x plus 4 equals 0. Now x plus 2 equals 0 or x plus 4 equal to 0. Now x equal to minus 2 and x equal to minus 4. At x equal to minus 2 and x equal to minus 4, this is the polynomial become 0. Let us check by substituting the values. First we are taking that x equal to minus 2. See here, in this polynomial, instead of this x, we are giving the value minus 2. So, minus 2 whole square. See here, x square. So, minus 2 whole square plus 6 into minus 2. See, 6 into x. So, here we are giving x 6 into minus 2 plus 8. So, minus 2 whole square is 4. The next 6 into minus 2. One is positive, one is negative. So minus plus is minus. So 6 into 2 is 12 plus 8. Now we got 4 plus 8 is 12. 12 minus 12 is 0. So p of minus 2 equal 0. The next we are taking the value x equal to minus 4. So p of minus 4 equal minus 4 whole square plus 6 into minus 4 plus 8. Minus 4 whole square is 16 minus 24 plus 8. So P of minus 4 is equal to 0. So we can say that a real number k is said to be 0 of a polynomial P of x if P of k equal to 0. Then what is the meaning of zeros of a polynomial? At what point the polynomial becomes 0? That point is called the zeros of a polynomial. Now we can see the geometric meaning of zeros of a polynomial. See here what the topic is: geometric meaning of the zeros of a polynomial. Geometric meaning means what? It means how we can represent this polynomial graphically. That we can explain that. The representation of zeros of a polynomial graphically. In graph, the zeros of a polynomial is the x-coordinate of the point where the graph intersects the x-axis. First, let us consider the linear polynomial. Linear polynomial is what? A polynomial of degree 1. And the general form of a linear polynomial is ax plus b, where a, b are the real numbers and a not equal to 0. This is a linear polynomial. Now, let us consider the example. Y equal to 2x plus 4. This is a linear polynomial. Linear polynomial means the degree 1. See the degree 2x plus 4. The degree is 1. Now, we have to draw the graph. We are representing this linear polynomial graphically. So, for drawing the graph, we need to find the values of y and values of x. So, we can list some values of y corresponding to x. So, first, I am giving the value x as minus 2. If I am giving that value minus 2, what we will get the value for y? So y equal 2 into minus 2 plus 4. See here, instead of this x, I gave that minus 2. X equal to minus 2. So 2 into minus 2 plus 4 equal to 0. Next, y equal to 2 into minus 1 plus 4. That means x equal to minus 1. So 2 into minus 1 is minus 2 plus 4 is 2. The next, y equal to 2 into 0 plus 4. I am giving that x equal to 0. So we are getting that 4. 2 into 0 is 0 plus 4 is 4. Next, x equal to 1. See here, x equal to 1. So why we are getting the value 2 into 1 plus 4 is 6. Now we can write in a tabular form. See x, the value in first row, the values of x. In the second row, values of y. See, x equal to minus 2. What we got the value? See here, x equal to minus 2. We got y equal to 0. See here, y equal to 0. X equal to minus 1. Y equal to 2. X equal to 0. Y is 4. X equal 1. Y is 6. By using this value, we can plot the graph. To plot the graph, first we need to draw the x and y axis. See here, this is the x axis and this is the y axis. Then we can mark the units. Next, you have to find the values first. See here, the first value is minus 2, 0. In graph, we need to take the first x point, then y. See here, this is the x-axis, this is the minus 2. See here, this is the minus 2 point. And 0. See, this is the y-axis, 0 is here. So this is the first point, minus 2, 0. I marked here. See here. The next point, minus 1, 2. See, in x-axis, this is minus 1. Then in y, 2 word. See here, this is the 2. So minus 1, 2. This is the point. The next, 0, 4. 0 is here, then 4. Here, mark it. Then 1, 6. See here, 1, 6 is here. Now we can join these points. See, join this point, we got the graph. See, this is y equal to 2x plus 4. This is the point minus 2, 0, minus 1, 2, 0, 4, 1, 6. In this graph, see this straight line intersects the x-axis at minus 2. See here, the graph of 2x plus 4 intersect the x-axis at minus 2. That means the zero of a polynomial is minus 2. The zero of a polynomial 2x plus 4 is minus 2. In general, we can say that a linear polynomial ax plus b, the graph of y equal to ax plus b is a straight line. See here, this is a straight line. And it intersects the x-axis at exactly one point. See, in one point, exactly one point it intersects the x-axis. That point is minus b by a. So this b by a, we can say that it is a zero of a linear polynomial ax plus b. How we can find this b by a, minus b by a? See, we can write as ax plus b equal to 0. How we can write this way? That means 0 of a polynomial means what? At which point this polynomial becomes 0. So we can write as this polynomial equal to 0. Now we can find this value of this x. So ax equal to minus b, then x equal to minus b by a. This b by a minus b by a equal, see here, this b is the constant term in this polynomial. See here. So minus constant term divided by coefficient of x. See here, the coefficient of x is a. So minus b by a equal constant term divided by coefficient of x. Now let us look for the geometric meaning of zeros of a quadratic polynomial. Quadratic polynomial is a polynomial of degree 2. The general form of a quadratic polynomial is ax square plus bx plus c, where a, b, c are the real numbers and a not equal to 0. Let us check with the example. So the example, y equal x square minus x minus 2. We have to draw this polynomial, the graph of this polynomial. So how? First we have to find the values of y corresponding to x. For that, first I am taking that minus 2. This x equal to minus 2. So minus 2 whole square minus 2 minus 2. See this minus 2. So minus 2 whole square is 4 minus, see here, this minus 2, this minus, it will become plus 2 plus 2 minus 2 is 0. So we got that 4. The next x equal to minus 1. See here, x equal to minus 1. So minus 1 square minus 1 minus 2 equal 0. The next x equal to 0. 0 whole square minus 0 minus 2 is minus 2. Next x equal to 1. 1 square minus 1 minus 2 is minus 2. X equal to 2. 2 square minus 2 minus 2 equal to 0. X equal to 3. 3 square minus 3 minus 2 equal 4. Now we got the values. Now we can write in a tabular form. See, in this x values, here it is y values. X equal to minus 2, we got 4. X equal minus 1, y is 0. X equal to 0, y is minus 2. See here minus 2. X is 1, y is minus 2. X is 2, y 0. X is 3, y 4. Now we can draw the graph. First we have to draw the x and y axis. Then mark the points. Next, the points we have to mark it. Minus 2, 4 is the first point. What is minus 2 in x-axis? See here, this. And 4. In y-axis, 4. See here the first point. Next, minus 1, 0. Where is minus 1? See here, minus 1. Then 0. 0 is here. So this is the second point. Next, 0, minus 2. So this is 0. Here it is minus 2. Next 1 minus 2. This is 1. Here it is minus 2. Next 2 0. Where is 2? See here it is 2 0. Next 3 4. 3 here 4. So 3 4. Now we can join these points and draw the graph. See here. This is the curve we got. See here y equal to x square minus x minus 2. These are the points we got. This is an open upward shape. See here, this is open and upward shape. The graph of a quadratic polynomial is either open upward or downward. It depends on a greater than 0 or a less than 0. These kind of curves are called parabola. In this graph, this intersect the x-axis at 2 points. See here, this 1 point and this is 2 point. See where this minus 1 and 2. So therefore, the 0 of a polynomial x square minus x minus 2 is minus 1 and 2. In this parabola, this polynomial having 2 zeros. But in quadratic polynomial, we can see 3 situations, 3 cases. The case 1, a graph of a quadratic polynomial cut the x-axis at 2 distinct points that we discussed here. This situation is that. See the graph? This is the parabola. This graph cut the x-axis at 2 points. See here? This A and A dash. These are the 2 points. In this case, quadratic polynomial has 2 zeros. See here also we got that 2 zeros were minus 1 and 2. 2 zeros here also A and A dash. These are the 2 zeros of this quadratic polynomial. The next case, the case 2, the graph cut the x-axis exactly 1 point. See the graph. This is the x and y axis. See, this is the parabola. See here this point, this A point. Here, this intersect the x-axis. Actually, this is the 2 point coincide the points. So, we are considering this as 1. In this case, only 1 0 for this quadratic polynomial ax square plus bx plus c. And the case 3, the graph does not cut the x-axis at any point. See the graph. This is the x and y axis. See, this is the parabola. The graph, see here, it does not touching the x-axis. The graph does not cut the x-axis. It is completely above or below the x-axis. Here it is completely above the x-axis. The quadratic polynomial ax square plus bx plus c has no zeros in this case. Completely upward or completely downward. In this case, no zeros. So, a quadratic polynomial can have either two distinct zeros or two equal zeros. That means one zero or no zero. Hence, we can conclude that a polynomial p of x of degree n has at most n zeros.